Now imagine standing at the very edge of everything you have ever known. Every city, every ocean, every mountain, every sunset, and realizing that all of it, every single thing you have ever loved or touched or dreamed about, sits on a tiny pale blue dot spinning quietly in one small corner of a galaxy so enormous that your mind literally cannot process its size. Tonight, we are going to attempt something audacious. We are going to try to answer a question that has haunted astronomers, dreamers, poets, and explorers for centuries. How long would it actually, truly, honestly take to cross the Milky Way galaxy from one end to the other? Not in theory, not in Hollywood science fiction, but in cold, breathtaking, humbling reality. And I promise you this, by the time we reach the end of this journey together, you will never look up at the night sky the same way again. You will feel both impossibly small and incredibly powerful at the same time. Because understanding the scale of where we live does not diminish us, it ignites us. So buckle in, open your imagination wider than it has ever been opened before, and let us travel together across the most magnificent structure any of us will ever call home. When we casually say the words Milky Way galaxy, most of us picture a beautiful glowing spiral that we have seen in textbooks or documentaries, a luminous pinwheel of stars suspended against the black velvet of space. But that image, as gorgeous as it is, does absolutely nothing to prepare your brain for the actual incomprehensible enormity of this structure that we call home. The Milky Way stretches approximately 100,000 light-years from one edge to the other. Now let that number sit with you for a moment before we even begin to unpack what it means. 100,000 light-years. That is not a distance measured in miles or kilometers, because if we tried to write it in those familiar earthly units, the number would be so long that it would lose all meaning. We are talking about roughly 587 quadrillion miles. To put that into a perspective that might begin to make sense, imagine lining up 100 trillion copies of the Earth side by side. You still would not stretch across the Milky Way. Our galaxy contains somewhere between 100 billion and 400 billion stars, and each of those stars is separated from its neighbors by distances so vast that even light, the fastest thing in the known universe, takes years to travel between them. Our own sun sits roughly 26,000 light-years from the galactic center, which means we are not even in the middle of this enormous cosmic city. We live out in the suburbs, tucked into one of the spiral arms, orbiting quietly while the galaxy itself rotates slowly over hundreds of millions of years. The disk of the Milky Way is about 2,000 light-years thick in most places, meaning it is not just wide, but also has considerable depth, like a massive cosmic frisbee with a bulging center filled with ancient stars and possibly a supermassive black hole weighing 4 million times the mass of our sun. When ancient civilizations looked up and saw that milky band of light stretching across the sky, they were actually seeing the combined glow of billions of stars so far away that their individual light blurred together into a river of luminescence. They had no concept of the distances involved, no way of knowing that what they were seeing was the interior view of a galaxy so large that even our fastest technologies would take longer than the current age of the universe to cross it. This scale is not just impressive, it is the kind of vastness that rewires how you think about existence itself, about time, about distance, about what it means to be alive in a cosmos. This breathtakingly light travels at approximately 186,000 miles per second, or about 300,000 kilometers per second, making it the absolute fastest phenomenon in the known universe according to everything we currently understand about physics. When you flip a light switch in your room, the light appears to fill the space instantaneously, and for all practical purposes on a human scale, it does. But stretch that beam of light across the cosmos, and suddenly this seemingly infinite speed starts to feel painfully, heartbreakingly slow. Light from the sun takes about 8 minutes and 20 seconds to reach the Earth, meaning that every time you look at the sun, you are actually seeing it as it was over 8 minutes ago. You are literally looking back in time. Light takes about 5.5 hours to reach Pluto at the outer edges of our solar system. It takes about 4 years and 3 months to reach the nearest star system, Alpha Centauri. And to cross the entire Milky Way galaxy from one edge to the other, light would need approximately 100,000 years. That means if you could somehow build a spaceship that travels at the speed of light, which according to Einstein's theory of special relativity is physically impossible for any object with mass, you would still need 100,000 years to make the journey. 100,000 years. Let that sink deeply into your consciousness. Modern humans, Homo sapiens, have only existed for roughly 300,000 years. Recorded human civilization is only about 5,000 to 6,000 years old. The entire span of everything we have ever built, every empire, every language, every piece of art, every war, every love story, fits into a window of time that is a tiny fraction of what it would take light itself to cross our galaxy. And light is fast. Light is the cosmic speed limit. Nothing that carries information or mass can exceed it as far as we know. So when astronomers use light years as a unit of measurement, they are not being dramatic or poetic. They are using the only yardstick that makes any sense at these scales because miles and kilometers simply collapse under the weight of these distances. The speed of light simultaneously reveals two truths about our universe. First, that the cosmos operates on scales of time and space that dwarf everything in human experience, and second, that even nature's ultimate speedster is humbled by the sheer size of the galaxy we inhabit, turning a crossing that sounds simple into a voyage spanning more time than civilizations have. Now let us bring this conversation back down to Earth, quite literally, and talk about the speeds that we as a species have actually achieved with our technology. The fastest human-made object ever launched is the Parker Solar Probe, which at its closest approach to the Sun reaches speeds of approximately 430,000 miles per hour. That sounds incredibly fast, and it is. At that speed, you could fly from New York to Los Angeles in about 20 seconds. You could circle the entire Earth in roughly 3.5 minutes. It is a genuinely extraordinary feat of engineering and a testament to human ingenuity. But now point that spacecraft toward the far edge of the Milky Way, and the math becomes devastating. At the speed of the Parker Solar Probe, crossing the Milky Way galaxy would take roughly 150 billion years. Let me say that again because the number is so large it almost slides off the brain without registering. 150 billion years. The entire universe is only about 13.8 billion years old. That means crossing the Milky Way at our fastest current speed would take more than 10 times the entire age of the universe. If you had launched the Parker Solar Probe at the moment of the Big Bang, it would not even be close to 10% of the way across the galaxy by now. The Voyager 1 spacecraft, which launched in 1977 and is currently the most distant human-made object from Earth, travels at about 38,000 miles per hour. At Voyager's speed, the crossing would take approximately 500 billion years, which is so far beyond any meaningful frame of reference that it enters the territory of pure abstraction. Even the New Horizons probe, which flew past Pluto in 2015 at about 36,000 miles per hour, would take a comparable amount of time. These numbers force us to confront an uncomfortable but important truth. With our current propulsion technology, we are essentially stationary relative to the galaxy. We are like ants trying to cross a continent. Our legs work, our determination is real, but the scale of the journey is so far beyond our current capabilities that it borders on the impossible. Chemical rockets, which have been the backbone of space exploration since the beginning, simply do not produce enough speed to make interstellar travel practical, let alone intergalactic or even cross-galactic travel. we would need entirely new paradigms of propulsion, entirely new ways of thinking about movement through space. To even begin to dream realistically about a light year is the distance that light travels in one complete year, moving through the vacuum of space at its constant speed of roughly 186,000 miles per second. When you calculate that out over the course of an entire year, accounting for every second of every minute of every hour of every day, for 365 and a quarter days, you arrive at a distance of approximately 5.88 trillion miles. That is one single light year. Now multiply that by 100,000 and you begin to approach the diameter of the Milky Way. The concept of a light year is one of the most elegant and simultaneously most humbling units of measurement ever conceived by the human mind, because it fuses two things that we normally think of as separate, time and distance, into a single concept. When we say that a star is 50 light years away, we are saying two things at once. We are saying it is roughly 294 trillion miles away, and we are also saying that the light we see from that star tonight actually left its surface 50 years ago. We are looking at the past. Every time we gaze at the night sky, we are time travelers. The deeper we look into space, the further back in time we see. This is not metaphor. This is literal physics. If an alien civilization on the other side of the Milky Way pointed a sufficiently powerful telescope at Earth right now, they would not see our modern cities or our satellites. They would see Earth as it was 100,000 years ago when Homo sapiens were still spreading out of Africa and Neanderthals still walked the planet. The light year matters not just as a scientific measurement, but as a philosophical tool. It teaches us that the universe does not operate on human timescales. It teaches us that our sense of now is a local illusion, that the present moment only truly exists in our immediate vicinity, and that the further out we look, the deeper into history we peer. The Milky Way is not just large in space, it is large in time. Crossing it means not just covering distance, but enduring time on scales that make the rise and fall of entire species seem like the blink of an eye. Light years remind us that we are embedded in a fabric of space-time that stretches and yawns in every direction, and that our little corner of it, while precious and meaningful to us, occupies an almost vanishingly small fraction of the since conventional propulsion cannot even begin to bridge the staggering distances within our own galaxy. Physicists and visionary thinkers have explored theoretical methods that might someday allow faster-than-light travel, or at least dramatically reduce travel times across cosmic distances. The most famous of these concepts is the warp drive, popularized by science fiction but actually grounded in a legitimate mathematical framework proposed by physicist Miguel Alcubierre in 1994. The Alcubierre drive works not by moving a spacecraft through space faster than light, which would violate Einstein's relativity, but by contracting the fabric of space-time in front of the ship and expanding it behind, effectively creating a wave that carries the ship along while the ship itself remains stationary relative to its local space-time. In theory, this would allow a vessel to arrive at distant destinations in far less time than light itself would take, without technically breaking the cosmic speed limit. The problem is that building such a drive would require exotic matter with negative energy density, something that has never been observed or created in any laboratory, and the energy requirements in the original formulation were equivalent to the mass energy of an entire planet or even a star. Recent refinements by various researchers have brought those energy requirements down significantly, but they still remain far beyond anything we can currently produce or even seriously plan to produce. Then there are wormholes, which are hypothetical tunnels through the fabric of space-time that could connect two distant points in the universe, essentially creating a shortcut. Einstein himself, along with Nathan Rosen, predicted these structures mathematically, and they are sometimes called Einstein-Rosen bridges. If a stable, traversable wormhole could be created or discovered, one could theoretically step in at one location in the galaxy and emerge at another location thousands of light years away in moments. However, every wormhole solution we currently know of in physics is either unstable, meaning it would collapse before anything could pass through, or requires the same exotic negative energy matter that the warp drive demands. There are also concepts like generation ships, massive vessels designed to sustain entire human communities for thousands or millions of years as they slowly cross the void between stars, and suspended animation, where travelers would be placed in a state of biological stasis to survive journeys lasting millennia. Some theorists have even explored using black holes as gravitational slingshots or harnessing the energy of entire stars through Dyson spheres to power interstellar engines. Each of these ideas represents humanity reaching toward the seemingly impossible, refusing to accept that the distances are too great, and insisting that if nature built a galaxy this large, then perhaps nature also hid within its laws a way for curious minds to, when we truly grapple with the question of how long it would take to cross the Milky Way, something profound shifts inside us. It is not just a math problem or an astronomy lesson, it is a mirror held up to the human condition, reflecting back to us both our magnificent ambition and our profound smallness. We are a species that has existed for a cosmically insignificant amount of time on a small rocky world orbiting an average star in the quiet suburbs of an ordinary spiral galaxy. And yet here we are, calculating distances to the edge of the galaxy, dreaming up warp drives and wormholes, sending robotic emissaries past the boundaries of our solar system, and refusing to accept that the cosmos is too large for us to explore. There is something deeply beautiful and deeply defiant about that. The Milky Way does not care about us. It does not know we exist. It is not designed for us, and it is certainly not scaled for our convenience. The distances between stars are vast enough to make travel between even neighboring systems a generational project, and the distances across the entire galaxy are so immense that they stretch credulity itself. And yet, knowing all of this, knowing that crossing the Milky Way at our current speeds would take more than 10 times the age of the universe, knowing that even at light speed it would take 100,000 years, we do not despair. We dream bigger. We push harder. We build better telescopes, design more efficient engines, imagine new physics, and inspire our children with the possibility that someday, somehow, we might find a way. This is perhaps the most important lesson the Milky Way teaches us. The value of a journey is not determined by whether we can complete it in our lifetime. The value is in the reaching, the questioning, the wondering, the refusal to look up at 100 billion stars and say it is too much. Every great achievement in human history started with someone confronting an impossible distance, whether physical, intellectual, or spiritual, and deciding to take the first step anyway. The pyramids were not built in a day, democracy was not perfected in a century, and the Milky Way will not be crossed in a millennium. But the trajectory matters, the direction matters. The fact that we are a species that asks the question, how long would it take to cross our galaxy, tells you everything you need to know about who we are and who we might become. We are not defined by our current limitations. We are defined by the scope of our. To every single one of you who has stayed on this journey with me from the first word to the last, thank you. Thank you for your curiosity, your patience, your willingness to let your mind stretch across distances that defy comprehension. The universe rewards those who dare to wonder, and by engaging with these ideas, you have already taken a step that most people never take. You have looked beyond the horizon of the familiar and into the vast unknown. I wish you the very best of luck in everything you pursue, whether your journey takes you across a classroom, across a career, across an ocean, or perhaps someday across the stars. Keep looking up, keep asking questions that feel too big, keep dreaming on a galactic scale. The Milky Way is waiting, and it has all the time in the universe. Thank you, and may your path forward be as luminous as the 100 billion stars that light our galactic home.